Welcome back for a mini lesson on terminating and repeating decimals. A terminating decimal is a decimal that ends. Think about like if you get terminated from a job, it means that you're not working there anymore. Some common fractions that hold this pattern are things like 1/5, -3/8, or just 1/8, 1/10, and so on. A repeating decimal is a decimal that has a pattern that repeats. So this goes on and on and on and on. Some common fractions that create a repeating decimal would be things like 1/3, 2/3, 2/11, 1/9. So 1/9 would be something like 0.11 repeating. And you always put this bar here to denote that it's repeating, that pattern goes on and on forever. 1/3 is 0.33 repeating, just like 2/3 is 0.66 repeating. I think you guys get the idea. So I'm going to show you an example of each and see like what's happening each time. So for example 1, we have 5/11 as a decimal. We want to write that as a decimal. So just like we did before, the 11 or the denominator goes on the outside. Underneath the radicand is a 5. I know 11 doesn't go into 5, so I automatically put in my decimal and 0 placeholder. And then 11 goes into 50 4 times without going over, which is 44. I borrow if I need to, just a remainder of 6. And I'm going to see if I add another 0, if that will go away. 11 goes into 65 times without going over, we get 55. If we subtract, it's a remainder of 5. Add another 0, so 50. 11 goes into 50 without going over 4 times, get 44. Remainder 6. Add a 0, bring it down as a placeholder. And it goes in 5 times again. So do you notice how when we keep going, we get the same remainder 6, remainder 5 over and over again? So we can write 5/11 as a repeating decimal as 0.45 repeating. Now make sure that bar goes over both of them because that pattern 4, 5, 4, 5 repeats. So there's an example of a repeating decimal. So your remainder will never be 0. Our last example for this mini video is going to be 4 1/8 as a decimal. So I know it's going to be 4 point something, just like before, but I'm only going to look at the 1/8 to divide it in. So 8 goes on the outside, add my decimal and 0. 8 goes into 1 0 times, but 8 goes into 10 once. 8 times 1 is 8, so subtract that. We get a remainder of 2. Add your 0 placeholder. And see how many times 8 goes into 20. Goes in twice. And you're probably wondering, well, how many times do I keep adding zeros and keep checking? I usually check to the thousandths place or 3 decimal places over from where your decimal place starts here. But that's just me. Sometimes you'll have to do it more often. Eight goes into 45 times. Subtract the 40, we get a remainder of 0. So this would be the decimal 4.125. This is a terminating decimal. And if you look at the difference between our first example and this example, you'll probably notice that the remainders are different. So this had a remainder of 5 or 4, or 6, but the remainder here is a 0. So terminating decimals always end with a remainder of 0. So that's a good way to remember the difference. Complete the U-try in your notes from 1 to 3, and then come see me.